powerful the amplifier, the more powerful the broadcast. Antenna converts the amplified signal to radio waves. Session 8. Title: Global System for Mobile Communication, GSM. GSM architecture and meaning of abbreviation. What is a SIM? The SIM provides personal mobility so that the user can have access to all subscribed services irrespective of both the location of the terminal and the use of a specific terminal. A phone without a SIM is known as a mobile equipment. A phone with a SIM is known as mobile station. The GSM network architecture consists of different elements that all interact together to form the overall GSM system. A GSM, Global System for Mobile Communication, network comprises of many functional units. The GSM network can be broadly divided into the mobile station, MS, the base station subsystem, BSS, the network switching subsystem, NSS, the operation support subsystem, OSS. Subsystems of GSM architecture: the base transceiver station, BTS, the base station controller, BSC, mobile services switching center, MSC, home location register, HLR, visitor location register, VLR, authentication center, AUC, equipment identity register, EIR, ABI's interface. Subsystems of GSM architecture: the base transceiver station, BTS. The BTS used in a GSM network comprises the radio transmitter receivers and their associated antennas that transmit and receive to directly communicate with the mobiles. The BTS is the defining element for each cell. The BTS communicates with the mobiles, and the interface between the two is known as the interface with its associated protocols. Base station controller, BSC. The BSC forms the next stage back into the GSM network. It controls a group of BTSs and is often co-located with one of the BTSs in its group. It manages the radio resources and controls items such as handover within the group of BTSs, allocates channels, and the like. It communicates with the BTSs over what is termed the ABI's interface. Mobile Services Switching Center, MSC. The main element within the core network area of the overall GSM network architecture is the Mobile Switching Services Center, MSC. The MSC acts like a normal switching node within a PSTN or ISDN, but also provides additional functionality to enable the requirements of a mobile user to be supported. Home Location Register, HLR. This database contains all the administrative information about each subscriber along with their last known location. In this way, the GSM network is able to route calls to the relevant base station for the MS when a user switches on their phone. The phone registers with the network, and from this, it is possible to determine which BTS it communicates with so that incoming calls can be routed appropriately. Visitor Location Register, VLR. This contains selected information from the HLR that enables the selected services for the individual subscriber to be provided. The VLR can be implemented as a separate entity, but it is commonly realized as an integral part of the MSC, rather than a separate entity. In this way, access is made faster and more convenient. Equipment Identity Register, EIR. The EIR is the entity that decides whether a given mobile equipment may be allowed onto the network. Each mobile equipment has a number known as the International Mobile Equipment Identity. Authentication Center, AUC. The AUC is a protected database that contains the secret key also contained in the user's SIM card. It is used for authentication and for ciphering on the radio channel. Gateway Mobile Switching Center, GMSC. The GMSC is the point to which a ME terminating call is initially routed, without any knowledge of the MS's location. The GMSC is thus in charge of obtaining the MSRN, mobile station roaming number, from the HLR based on the MSISDN, mobile station ISDN number, the directory number of MS, and routing the call to the correct visited MSC. Authentication Center, AUC. The AUC is a protected database that contains the secret key also contained in the user's SIM card. It is used for authentication and for ciphering on the radio channel. Gateway Mobile Switching Center, GMSC. The GMSC is the point to which a ME terminating call is initially routed, without any knowledge of the MS's location. The GMSC is thus in charge of obtaining the MSRN, mobile station roaming number, from the HLR based on the MSISDN, mobile station ISDN number, the directory number of MS, and routing the call to the correct visited MSC. Topic 3. Principle of operations during conversation. When you speak into a cell phone, a tiny microphone in the handset converts the up and down sounds of your voice into a corresponding up and down pattern of electrical signals. A microchip inside the phone turns these signals into strings of numbers. The numbers are packed up into a radio wave and beamed out from the phone's antenna. In some countries, the antenna is called an aerial. The radio wave races through the air at the speed of light until it reaches the nearest cell phone mast. The mast receives the signals and passes them on to its base station, which effectively coordinates what happens inside each local part of the cell phone network, which is called a cell. From the base station, the calls are routed onward to their destination. Calls made from a cell phone to another cell phone on the same network travel to their destination by being routed to the base station nearest to the destination phone, and finally to that phone itself. Calls made to a cell phone on a different network or a landline follow a more lengthy path. They may have to be routed into the main telephone network before they can reach their ultimate destination. Principle of operations: on-net and off-net call setup. The terms on-net and off-net are used to describe call or messaging types. On-net is used when your call or message originates on your home operator's network and terminates to another mobile number that resides with your operator. It does not matter if the person you are calling is using the home network or is off-island roaming with a different provider. Off-net applies when the call or message is made on a different network, e.g. whilst you are roaming, or if you are using your home network and make a call or send a message to a number that resides with a different network provider. On-net, when one places a call, it goes through to the BTS through the ABI's interface. As the ABI's interface is responsible for transmitting traffic and signaling information between BSC and BTS, the BTS correspond to the transceiver and antenna. It is used in each cells of the network. It is usually placed in the center of a cell where antenna is located. It actually picks the signal and send it to BSC. The signal is then moved to the MSC. It preforms switching of calls. It communicates with the surrounding database. The MSC is surrounded with 4 functional databases such as HLR, VLR, AUC, and EIR. The VLR register will request information or data of an individual from the HLR. The VLR function in a way that it doesn't put pressure on the HLR. The AUC makes sure that all the secret codes enacted in each subscriber's SIM is protected. The EIR check of standardization for international recognition. The signal goes to the receiver using the antenna. The mobile station is located and the receiver is alerted. OFFnet, the process is almost the same. However, over here the data or information of the caller will have to be obtained from the HLR. Because of the MSC usage, the receiver station says Vodafone will get some percentage before the data of the receiver will be released for the call to be completed. That's why calls with different networks has high call rate charges than call between the same network. Application of signal-to-noise ratio. A signal-to-noise ratio compares a level of signal power to a level of noise power. It is most often expressed as a measurement of decibels, dB. Higher numbers generally mean a better specification, since there is more useful information, the signal, than there is unwanted data, the noise. For example, when an audio component lists a signal-to-noise ratio of 100 dB, it means that the level of the audio signal is 100 dB higher than the level of the noise. A signal-to-noise ratio specification of 100 dB is considerably better than one that is 70 dB or less.